implemented my very first program in Scratch when I was a graduate student, actually, at MIT, cross-registered at MIT, taking a class from MIT's Media Lab, specifically the Lifelong Kindergarten group, which is the group that created Scratch itself. And the program I wrote all those years ago and still rather cling to is a little something here called Oscar time that I thought I'd play just a quick excerpt of myself here. So in this case, consider as the music starts playing how this program, which is much more sophisticated certainly than the earliest say hello example, more sprites are suddenly appearing. And notice that each time they're appearing from a different part of the screen. That's an allusion perhaps to that to pick a random number between x and y. So you can actually pick some range of values to have the game constantly changing. And indeed, I'm going to go ahead and click stop since I spent like 8 hours plus years ago making this and I can never listen to the song again. Not that I should be anyway at this point in my life, but this song is synchronized then with a lot of the actions that's happening. And ultimately, there's just a lot of building blocks. But I didn't sit down and implement Oscar time, as I called it, all at once. I really did take baby steps, so to speak. And I figured out, well, how could I decompose this vision I had at the time to create this game ultimately? And how do I bite off maybe the easiest parts first? And honestly, the first thing I did was I found this image, and I just like dragged and dropped it into Scratch. So, OK, done. Like lamppost is installed. It doesn't do anything. It's not interactive, but I at least set the stage, so to speak, for the program. Then what else might I have done? Well, let me do this. Let me go ahead and open up in another editor here a early incarnation of Oscar time by doing this. Let me go into Oscar time here. Let me full screen this. And here you have, let me hide the trash for just a moment, is what I might call the second version of my program, wherein at the top right of the stage here, I had the lamppost, which I just dragged and dropped and got going, but then I added an actual sprite. And it has to be a sprite if you wanted to do things interactively. The lamppost, not a sprite. It's just an image, a costume, if you will, for the whole stage itself, a backdrop. But this thing is indeed a sprite because it needs to respond to code and events like dragging and dropping. So what might I have done early on with that code? Well, maybe the first version would have been something like this, whereby my very first version of Oscar time might have said something like, oh, this. How about let me control the program as before, or rather events. When the green flag is clicked, what do I want to do? Well, I want to go ahead and forever do something like this, forever. So I want the lid to open up if I touch it. So if the cursor gets near the lid, I want the lid to open up. And then if I move away, I want it to close. So how can I do that? I want an if, but I just don't want one question. I really want two, a fork in the road that goes left or right, so to speak. And let me grab this puzzle piece here as I did long ago. So notice it grows to fill. What's the question I want to ask? Well, under sensing, I'm going to go ahead here and say if this trash can is touching the mouse pointer, what do I want to do? Well, I want to change what the trash can looks like. And this part I did in advance of class. If you go up here to costumes, this is where all the graphical stuff happens. And you'll see that I imported a whole bunch of different costumes that effectively, much like a video, when you play them quickly, creates the illusion of movement, some animation. But it's really just dot, 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 different images showing on the screen. Well, some of these costumes are called like Oscar 1, Oscar 2. Oscar 1 is closed. Oscar 2 is open. So let's just deal with those first. So if I'm touching the mouse pointer, let me go under, how about looks? And we didn't use this before, but there's this block. Switch costume to something else. I'm going to drag and drop this inside of the if. And notice it's a little bit indented. I'm going to change it not to Oscar 8, but Oscar 2. Otherwise, if not touching the mouse pointer, this is the other direction in the fork in the road, let's go ahead and switch the costume back to what I described as Oscar 1. So let me run this program. And not much of interest is happening yet. But notice if I move the cursor up, down. But how is that working? It's just changing the costume that's being overlaid on the sprite. So it looks like interactivity, but you're really just changing the aesthetics. And we humans are just kind of, assuming, oh, it's opening up. Well, no, it's just changing a costume. So here's the difference. The high-level abstraction, trash can opening. The lower-level implementation detail, costume changing, creating that illusion. And if I wanted to look prettier, I could just have many other costumes and go boom, 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 boom to create more frames per second, if you will. So I need to do one other thing. Maybe if I accidentally leave the trash can open, let me make one change here. Let me make sure that the very first thing I do when the green flag is clicked is always start with the trash can closed, because otherwise you might accidentally leave it open. So this gets me into some default state. So now it's always closed until I manually hover over it instead. Well, what might I have done next? Well, if I wanted to introduce something like the trash, I need a second sprite. And here in advance, I grabbed the image already. Let me pretend that this never happened. Let me drag this away here. And now I have nothing in my code area for this piece of trash. But it is a second sprite. And all I did was I clicked on the little cat plus icon here, created a second sprite. I named it trash. I added a costume for it. Sort of the aesthetic stuff I did in advance. But here I'll do now the code. How do I want to do this? Well, how about when the green flag is clicked for the trash can, I want the trash can in parallel to do, or I want the trash, the piece of trash, to do its own thing. So what I want it to do is maybe, let's do motion, how about? And let's go to a specific coordinate. Now, there's a lot of options here. There's turning, go to a random position, go to x, y, glide more elegantly. There's a lot of different ways to implement movement. I just wanted to go to a very specific location first. So I'm just going to go to x, y first. And I'm going to say x, how about will be, let's not hard code this. Let's just have it be, well, let's do it as 0 initially, and then 240. So whoops, let's do 0, 240 so that this piece of trash always starts at the top middle of the screen if you think back to that coordinate system. 0, 0 is in the middle, 240 is straight above it. All right, now after I do that, what do I want to do? Well, how about I control this thing by forever falling? Now, how do I make the trash move? We haven't seen this puzzle piece yet, but under motion, the very first thing is called move some number of steps. By default, it's 10, but we'll do it more simply. Let me go ahead and move. Move is going to move it in whatever direction it's facing. I only want it to move down. So here, even I'm getting confused as to how many different ways there are to do things. What I think I want to do is this. Let me only change my y-axis as follows. So here's another puzzle piece called change y. So again, y is the vertical. So let me just change y by 1 pixel downward at a time. So -1, 1 pixel at a time. So it's kind of slow. And I think that's it. Let me hit stop. Notice that my trash can is still going to be interactive. I haven't changed or deleted that code. I've just added now code for my trash piece of trash. If I click the green flag, notice that after I enable it, let me start that again. I had it hidden before class, but let me enable it now. Green flag, notice it starts dead center at x equals 0, y equals 240, and it's dropping 1 pixel at a time. If that seems a little boring, we can change it to -10 pixels at a time, and boom, it's done. So that's how you might change the speed of a program. But I'm going to leave it more simply as -1. And honestly, it would be nice if it doesn't always start from the top. Otherwise, this game is not going to be very interactive. I'm literally going to be grabbing the trash from the same place every time. So why don't I instead stop this? Let me go under operators, and let's pick a random number. So let me change the hard-coded, the manually inputted 0, and let's make x be somewhere between 0, so in the middle, and all the way over to, what was it, I got my numbers wrong, 240, and my y will be 180. Sorry, I got my x and my y confused. So let me play this again. And now we have a game that's more like games you might have played growing up, or even now, like there's some randomness to it. So the CPU, so to speak, is doing something more interesting. Let me run it again. Now it's a little to the left. Let me run it again. Now it's a little more to the left. Again, now it's back to the right. So randomness just makes games more interesting. And this is why when you play any video game, if different things are happening, there's probably just some randomness. And it's quantized as just a simple number. Now I think I just need one final flourish here, if I may. Let me go ahead and add this. How about events or rather, yes, events, when green flag is clicked, I can do multiple things within the same sprite. They don't all have to be attached to the same one. Let me go ahead and forever go ahead and do something else. How about whenever the trash is, how about touching the trash can? So forever, if, let's see, I need a sensing block. So how about is touching, not the mouse pointer this time, but touching Oscar himself there. Now let's see what happens. All right, so let's go ahead and click the green flag. Now I go down over here and let go. OK, I kind of want it to go into the trash can. How do I make it go into the trash can? How can we take this high-level idea, put trash into the trash can, and make it seem to disappear? Logically, what could we do? Yeah. OK, so when it touches it, let's have it disappear. So I could hide it. Or honestly, if the game's going to be ongoing like it was, letting me drop more and more trash, let me just have it go ahead and pick a new random location. So let me do this. Let me go ahead and copy this puzzle piece up here and duplicate. And I don't want the whole thing. Sorry. Let me get rid of this. Let me just do this. Let me go back to some random location at the top. So now notice what happens. If I click and drag on it, here it goes, and I let go, it looks like it's going into the trash can because it snaps back up to some random location. Now, the only thing I'm not doing really is keeping track of any kind of score. And it turns out if I full screen this, it's not going to be draggable by default. So just as a corner case, so to speak, something that you might trip over otherwise, let me go ahead and under, let's see, sensing, it turns out I also need this for the piece of trash. There's this way of setting in Scratch a sprite to be draggable or not draggable. I need to explicitly make it draggable so that when I do full screen this thing now, it still remains draggable. And someone like myself can play it again and again. Well, how about we supplement this with one final flourish? Why don't we keep track now of the user's score? So how about when the user actually drags the piece of trash to the trash can? Let me go under variables here where in advance I've already made myself a variable called score. I could have called it X or Y or Z or ABC, but that's not very descriptive. In programming, you typically give things a more descriptive English or some other language name. So I called this one score. So how do I want to do this in my score? Well, let me go ahead and initially set this game's score to 0 at the very top of one of these scripts, or one of these programs up here. And then any time my cursor, my piece of trash is touching Oscar, let's not just jump to the top. Let's change the score by 1 up here. So now notice, if touching Oscar, change the score, that is, add 1 to the score, and then pick a new random location. And now, green flag, let's do this slowly. Here it goes. It's the trash can opens. I let go. And now notice at the top left of my program, notice the score is now 2. Notice the score, if I do this again, is about to become 3. And so here we have building blocks, literally, of making this program better and better and better. And so indeed, that's how you generally approach solving any large program, any problem with code, be it in Scratch or C or Python or some other. You take this vision you might have, or some vision you've been assigned in a homework assignment, and try to break it down into these constituent parts. And just pluck off the easy ones first. Put the lamppost there first and at least feel like you're making some progress. Then pluck off something like the trash can and just make it do a little thing. And it doesn't have to be in some same order here. I could have done this in a million different ways. But figure out what the small pieces are that ultimately, like a few of the problems we've solved today, assemble into a greater solution there too. So that you have now a mental model for these types of blocks and others, let's return for a moment to this. We saw a moment ago that when I started saying, hello, David, and nesting those puzzle pieces, we had a whole different paradigm altogether. My input for that second version of hello world was to now pass in, for instance, what's your name, into my function called ask. That gave me not a side effect, but what I called, again, a return value called answer by default in Scratch. And now notice and recall, when I had that same output become the input to my next block, it looked a little something like this, say. So how does this type of block and this nesting, this stacking of blocks fit into the same mental model? Well, same idea. My input for that part of the story is now taking in not one input, but two arguments, hello and the answer from before. The function in this case is that new block called join. The output thereof is hello, David, which itself became, if we sort of animate this, the input to my final function, which indeed was still say. And this is only to say, no pun intended, that almost everything that you do with these puzzle pieces, be it in the context of Oscar time or the mole whacking or even just something simple like Hello World, will ultimately fit into that relatively simple mental model there. Now, I thought we'd end by taking a look at just a couple of final examples, these ones too made by some of your predecessors. And for this, I thought we would not write code together, but read it instead. And so allow me to open up one other example here that will show us a few different versions of a program that a predecessor made. Give me just a moment here, and we'll see how we might build up to something even more interactive. And in just a moment, we'll see something they called Ivy's hardest game, focused here on these particular mechanics. So here is version 0, so to speak, of this program, wherein the goal was to create a game where you have to like get out of some kind of maze. And you have to get out, in this case, the Harvard crest from this maze. Let me go ahead and just hit play on this green flag so you can see what the first building block for this program might have been. Notice that my hand here is actually on the arrow keys of my keyboard. And it seems that by moving up, down, left, or right, this little crest on the screen responds in exactly that way. Now let's hypothesize for just a moment, even though we've not done anything quite like this before, how might this code be implemented? How do you get a sprite, be it a cat or a crest, to respond to keys on a keyboard? Might you think intuitively? Yeah. Yeah, there could be something sensing what key you're pressing on. And if you do it again in a forever loop, you'll just constantly be listening for keystrokes. And this is how like every piece of software nowadays works. It's constantly waiting for your phone to be tapped or something to be typed on the screen. So let me go ahead and look inside of this existing program here. And there's more going on, but we'll take a quick glance. What's actually going on? Well, up here at top left, notice we just have go to x equals 0 and y equals 0. That means put the Harvard crest dead center in the middle of the stage. Then we have forever two functions that we made in advance as custom functions. Listen for keyboard, feel for walls. So it's doing two things at once. It's forever listening for the keyboard, up, down, left, right, and feeling for the walls in the sense that if I get too far to the left, I don't want it to keep moving past that black wall. And if it moves too far to the right, I don't want it to blow through that wall either. So it's going to do two things constantly, listening for keyboard and feeling for walls, so to speak. And how are those implemented? Well, this one's a bit long, but on the left here is listen for keyboard. So this pink puzzle piece, listen for keyboard, first checks if the key up arrow is pressed, question mark, Boolean expression in a conditional, change y by 1. That means move it up 1. Else if the key down arrow is pressed, then change y by -1. And similar for left arrow, similar for right arrow. And even though there's not a loop in this pink function, there is where I'm using it. So it's constantly being asked again and again. How about feeling for walls? Well, over here to the right, it's a little cut off, but here you have if touching left wall, change x by 1. So if you hit the wall, it's too late. You're kind of blowing through it already. So I want to move it whack 1 pixel so it's no longer touching that wall. Similarly, if it's touching the right wall, I want to back it up 1 pixel so it's no longer touching that wall. So it's kind of like bouncing off ever so slightly so that it doesn't slip through that actual wall. And what are those walls? Well, notice down here, it's just a simple sprite with a black line that I've oriented vertically instead of horizontally. And that's just so that I can ask questions of these other two sprites. Now, that gives me that form of interactivity. What more can I now do? Well, what if we make things a little more interactive here? Let me go ahead and see inside version 1, our second. And let me propose what's going to happen here. Well, how might we add a little something like Yale into the mix? Well, what's Yale going to do when I hit the green flag now, based on this code? Any hunches? Here is the code for my Yale sprite. Yeah. Yeah, it's kind of going to be an adversary by blocking my path, theoretically, if I keep writing more code. So why? It, too, goes to the middle of the screen. It points in direction 90 degrees. So similarly, there's a whole degree system as well. And it forever asks this. If touching the left wall or, notice the green block, touching the right wall, then just turn around 180 degrees. And indeed, if you think this through logically, that just means you're bouncing this way and this way by just flipping yourself around 180 degrees for just this Yale sprite. So if I go ahead and zoom in on this and click the green flag, I can still move up and down, But Yale is just kind of doing this all day long, back and forth forever. Nothing bad happens if I try to go through it, but we could add that certainly to the mix. In fact, let's add one final feature before we play this particular game. And let me go ahead and open up the final version of these building blocks that adds MIT to the mix. So here's MIT. Someone want to explain what this code does? And this is what we're doing. This itself is a skill. Reading someone else's code and understanding it is half of the part of programming besides writing. Yeah? Yeah, it's chasing down the Harvard logo outline. So this is apparently the name of the costume that this student made, Harvard logo outline. And apparently it goes to a random position first, but then it forever points to Harvard. So no matter where I'm moving it, up, down, left, or right, MIT is being a little more strategic than Yale, bouncing back and forth like this. So let's go ahead and play this one in full screen. And here we have a green flag. So if I move up, MIT, rather strategically, is following me no matter where I go. All right, so still nothing bad happens, but and now it's struggling, right? It's going up, down, up, down. It's trying to follow me even though I'm not moving. So we need some final flourishes. And so I think for this, we need perhaps one final volunteer. After this, cake awaits for everyone outside, as is an end of first lecture CS50 tradition. Would you like to come up and be our volunteer? All right, and so this will be the actual version written by one of your predecessors that I'll full screen here. It's going to stitch together all of these same primitives and more, but add the notion of scores and lives so that there's actually a goal, which in this case is to move the Harvard crest to constantly pursue the character on the right-hand side so that your sprite touches that one. Would you like to introduce yourself?
Hi, my name is Mohammed.
All right, wonderful. Welcome aboard. And here we come with some instructions and final flourish if we want to keep the lights up but perhaps increase the music. Notice he's using the up, down, left, right, but there's many more walls now. First level's pretty easy, but now Yale's in the mix. Bouncing back and forth. Again, pretty easy. Now there's two Yales at slightly different positions. MIT is coming soon, but first we have three Yales. Very nice. Gotta go quick. Oh. Second to last level. Last level. Congrats. All right, that's it for CS50. Welcome. Cake is now served. We'll see you next time.